Good day everyone, we are the Group 5 and today we will be discussing the greedy algorithm. I am Francheska Recierdo and joining me are Gabriel, Concepcion, Francheska Recierdo III and Regalado. We are excited to walk you through this problem-solving approach and show where it's commonly used. A greedy algorithm is a problem-solving procedure that aims to find locally optimal solution by progressively building candidate solutions at each stage based on the level of improvement. While it may not be guaranteed the global optimal solution efficiently. So a greedy algorithm works by taking the best immediate option at each step, hoping it leads to the best overall solution. It doesn't always guarantee the most optimal solution globally, but it's efficient and often works well for many practical problems. Here are some common examples of where greedy algorithms are used. This includes the cashier algorithms for giving change, interval scheduling for selecting non-overlapping tasks, and optimal coaching, which is used in memory management. So each of these problems can be approached effectively using the greedy method. Next, we have a sample problem for cashier algorithm. So this is the problem. During your free time, you work at a nearby grocery store to help your parents save money and pay your bills, especially now that we are still in the recovery from the post-pandemic effects. In the grocery store, you need to work efficiently to avoid long lines at the counter. You are also paid depending on the number of customers you have served for the day. However, the cash register box only contains a limited amount of money and will only be refilled once a day. For you to be able to cater as many customers as possible, you need to give each customer an exact amount of change if needed with the fewest number of bills and coins. So the other member will explain to you on how to solve this type of problem.
We have a table that shows two columns, the price to pay and the payment for 5 different customers. The price to pay column shows the exact amount that the customer needs to pay. The payment column shows how much the customer actually gave. This means that for each customer, we will have to calculate how much change they should receive. This given information is important because it's the basis for solving the problem of giving back change using the least number of coins in bills, which we will tackle using a greedy algorithm. The first customer needs to pay 1,724 pesos and 25 centavos and gives 2,000 pesos. So the customer has change of 275 pesos and 25 centavos. We need to give the customer an exact amount of change with fewest number of bills and coins. We will start with the highest amount of denomination that fit to the total of change. So 1,500 is not fit. We skip now to 200. 200 is fit in the total change. So we subtract 200 in 275. So there's only 75.25. 100 is not fit in 75.25. And we skip now to 50. 50 is fit in 75.25. So we subtract again. So there is only 25.25. 20 is fit in 25.25. So there's only 5.25. 10 is not fit in 5.25. So we skip now in 5. Now 5 is fit, so there's only 0.25. 1 is not fit in 0.25. So we skip now on 0.25. 0.25 is fit in 0.25. Therefore, there are 5 combinations of denomination to complete the exact amount of change. The second customer owes 1,652 pesos and 55 centavos and pays 1,700 pesos. So the customer has change of 47 pesos and 45 centavos. We can see that 1,000 to 50 is not fit in 47.45. So we start in denomination 20. So there are 2 of 20 is fit in 47.45. That's why we put 2 in a row. So we subtract 40 in 47.45. So there's only 7.45. 10 is not fit in 7.45. So we skip now at 5. 5 is fit, so we subtract this 5 in 7.45. So there's only 2.45. 1 is fit in 2.45 and 2 of 1 is fit in 2.45. Now we subtract 2 in 2.45. So there's only 0.45. So in 0.25 is fit in 0.45. And we subtract 0.25 in 0.45 and there's only 0.20. 0.10 is fit in 0.20 and 2 of 0.10 is fit in 0.20. So we subtract again the 0.20 in 0.20. And therefore there are 8 combinations to complete the exact amount of change.
Hi everyone, my name is Regalado, and in this video, I will be the one who will walk you through in real-world applications of greedy approach, particularly focusing on examples 3 to 5 from our change denomination problem. So let's get started. First is in example 3, which is a customer needs to pay 508.15 pesos and pays with 520 pesos. That leaves us with 11.85 to return, or as we can see here, the change. So using the greedy algorithm, we aim to give this change using the least number of bills and coins. So starting with the largest denomination under 11.85 pesos, which is the change, we will give first one 10 peso, as we can see here in 10 peso. There is 1. Then next is 1 peso. Next is 3 25 centavo and 1 10 centavo, which is total of 6 pieces. So next is in example 4, which is the item cost 56.45 pesos and the payment is 100. So the change is 43.55 pesos. So as we can see here, there is a change of 43.55 pesos. So we again start from the highest possible denomination. So that will be a 2 20 bills, a 3 1 peso coin, a 2 25 centavo, and a 1 5 centavo coin. So the totals of 8 coins and bills combined. So as we can see here, the total is 8. So next is in example 5. So this will be the simpler. So the customer pays 200 for an item worth 175, which results in 25 pesos in change. So as we can see here, the change in the 200 peso that he or she pays is 25 peso. So here the optimal change is just 1 20 bill and a 1 5 peso bill. Only 2 pieces in total. So the greedy method efficiently minimizes the number of notes used. So we can see here that only 2 bill used in the change. Now, so next is the conclusion. So to conclude, the grid algorithm is highly effective in scenarios like this. So conclusion is in grid algorithm proves to be a powerful and efficient method for solving optimization problems. We're making the locally optimal choice at each step leads to a globally optimal solution. So its simplicity, speed, and low memory usage make it ideal for real-time applications such as change making systems in retail environments. However, while the greedy approach works effectively for problems with specific properties like a canonical coin systems, it may not always yield the best solution in more complex scenarios. So, therefore, while the greedy algorithm is a valuable tool in many cases, carefully consideration of the problem's nature and is essential to determine its suitability. So, in addition, like I said earlier, the grid algorithm is highly effective in scenarios like this where making the best local choice, like choosing the highest denomination available, leads to a good, often optimal overall result. So it's simple, fast, and perfect for systems like cash registers. However, remember that it doesn't always work well for more complex irregular problems. So that's all, and thank you for watching.
So, hello po. My name is Gabriel Concepcion. So, I am the one who assigned to explain the code and how the program works. So, earlier, my group mates tackled about grid algorithm. Richard is tackled the introduction. Then, Regalado and Berger is the one who solved the problem. So, example problem. So, So today is I will be the one who explain the code and how the program works. So let's start. So this program Python program is it simulate a cashier system where the user enter a price and the customer's payment, and the program calculates that change using the list number of coins and bills following a grid approach. So dito sa code natin, so as you can see, we have here a denomination. So itong denomination, may sa loob niya is may list yan, list ng Philippine currency. So naka-descending order siya, which is from higher to lower. Next, here is a history. So itong list name history is used to store the data. Store the details of each transaction for future reference and table display. So next is we use a while loop. So while loop, inside the while loop is may input tayo ng price to pay and payment. So and then the program calculates the change based on price and payment. So yung price minus nyo lang sa payment, so we will get the change. So here is a change denomination. So change breakdown. Then here is a change breakdown, and here is a show table of change denomination. So naga tayo ng show table if gusto nyo i-show yung table natin. Then lastly here is nag-add po ako ng exit option para hindi na tayo pa ulit-ulit na kasi minsan is magra-run ka ng code, then after one example is ulitin mo nun, magra-run ka for another example. So nag-add na ako niyan para hindi na mahirapan. So para mas maintindihan niyo po, I will show you how the program works. I-run natin. So earlier, Verga and Regalado is they tackle the sample and how it get and it's solved. They tackle is a 5 sample. Now is I will explain here. I will try the 5 example. So let's see. So earlier, the first example is 1724.75 yung price to pay niya. Then payment niya is 2,000, let's say 2,000. So as you can see, the calculates niyang program natin, yung change niya 275.25. So, sa change denomination, sa 200 may isa tayo, sa 50 isa, 20 isa, sa 5 isa, 0.25 isa. Pag kinalculate nyo yan, ito, so total niya lang is 275. So, dito, isa, dalawa, tatlo, apat, lima. So, total combination niya is 5. So, next is a show table. Kung gusto niyo show yung table, yes. So, yan na. Ito na yung kaninang sinold ng ating group mates. So, exit, no. So, we have another 4 example. Price to pay. Second example natin is 1652.55. Yung payment niya is 1,700. So, as you can see here, change denomination sa 20, dalawa, isa sa 5. Sa 1 is dalawa, 0.25 isa, sa 0.1 is dalawa. Total of 8 combination. Show table, yes, let's show the table. So, we have here is a show table based on this, change denomination. Exit, no, we have another 3, price to pay. Yung third example natin is 508.15. Then yung payment niya is sa 520. So, as you can see here, change denomination, yung change is 11.85, yung change denomination niya, isa sa 10 pesos, sa 1 is isa, 0.25 tatlo, 0.1 is isa, total of 11.85. So, total combination niya is 6. Show table, so ito yung table niya. Lastly, another 2 example. So, ito. Yung fourth example natin is 56.45. Payment niya is 100 pesos. So, change niya is 43.55. Change denomination. So, total combination is 8. So, show table. Yun. Last example. Price to pay. The last example we have is payment price to pay 175. For payment is 200. So, change niya is 25 pesos. Yung change denomination niya, isa sa 20, isa sa 5 pesos. So, total of 25. Yung total of combination niya is 2. So, show table. So, exit na tayo kasi wala na tayong example. So, exiting program. Goodbye. Thank you. So, that's our program works. Implementation of grid algorithm in a cashier system. So, that's all po. Thank you for listening and bye-bye.